Okay, number 4, again, we're going to find f of g of x and g of f in the domain of each. So this time, f of x is 6 over 1 minus 5x, and g of x is just 1 divided by x. Okay, so find the domain of each of them individually. So the domain of f, since we have a fraction, we have to take the denominator, set it equal to 0, or not equal to 0. So x, or actually 1 minus 5x cannot be equal to 0. We're going to solve for x. We move the 1 over, we subtract 1, so we get negative 5x cannot be equal to negative 1. Divide by negative 5, and we get that x cannot be equal to 1 over 5. When you divide, negative divided by negative is a positive, so that's why I have 1 over 5. So this is your domain. 1/5 cannot be used. If x is 1/5, the denominator will be 0. Alright, domain of g. Again, take the bottom, set it not equal to 0, so x cannot be 0, and that's all we get. So we cannot use 0. We're done at that point. Okay, these are important because these restrictions will follow you once you do f of g of x or g of f. Only one, the one that you plug in, will follow. So we want to do f of g of x first. F of g. So I am going to, I should have put the parentheses here. I don't need that one. I'm going to start with f, and then whenever I get to x, I'm going to replace x with the g of x equation. So I start out with a 6 on the top divided by 1 minus 5x. Okay, so the x is going to be replaced with the g of x equation. So it's going to be 1 minus 5 times 1 over x. Okay, or we can rewrite this as 6 over 1 minus 5 over x. Just multiply that whole number, goes to the top. We need to simplify this. They will not let us insert the problem like this. And here's why that restriction follows you. So if you were to leave the function like this and you plug in a 0, you are dividing by 0, which you cannot do with a fraction, so that causes a problem. But we're going to simplify this and make this equation look better. If you have a fraction, you have a numerator, you have a denominator. In your denominator, you have another fraction. The simplest way to solve this is to find the least common multiple of the numerator and the denominator. So when I say numerator and denominator, we're going to look at this 6 as being 6 over 1. It's the same thing. So the denominator here and the denominator here. Least common multiple would be x. We just multiply those together. And so we're going to multiply top and bottom by x. Okay, that's our common denominator. So when I multiply just 6 times x, I'm wrapping around here. When I multiply 6 times x, I just get 6. And then on the bottom, when I multiply x times 1, that just gives me x. And when I multiply x times the 5 divided by x, multiplying by x and dividing by x at the same time will cancel out. That leaves us with x minus 5. So this is the function that we want to refer to as f of g of x. F g x. Okay, this is our f of g of x. And from here, we need to find the domain of this whole function, keeping in mind that we need to carry this one with us because that's the one that we plugged in. So from this function right here, the domain, we have a fraction, so x minus 5 cannot be equal to 0. When I add 5 to the other side, I get that x cannot be equal to 5. And I also want to bring down the 0. So these two numbers are restrictions. They're going to want us to write our domain in interval notation. So do a number line, put 0 on the number line and 5 on the number line. This is negative infinity. This is positive infinity. These two numbers will be removed. So we have from negative infinity to the left side of 0, and then we union the right side of 0 up to 5, and then we union the right side of 5 up to infinity. So we'll have 3 pieces. Removing these 2 points breaks our number line into 3 portions. So first, our functions are f of g of x right here. I'm going to do 6 divided by x minus 5. Make sure we're looking at this correctly. 6x. I don't know why I didn't write my x down. I said 6x, so it should be 6x on the top. That's my mistake. From here, I didn't bring my x over. I said 6x, but I didn't write 6x. 6x. There we go. Okay, and they don't want the domain yet. They want us to do f of g of x, so let's do that one. G of f of x, that is. So with the g of f of x, I will start with the g, and I'm going to plug in the f equation. So g is just 1 over x. Instead of x, we're going to replace the 1 over x with that whole equation, which is 6 over 1 minus 5x. Now here we just had that scenario, a fraction within a fraction, so we'll just change flips. So that means keep the top, change division to multiplication, and flip the fraction. So 1 minus 5x over 6. Multiply straight across. 1 times anything is itself. This is our f of g of x, or g of f of x function. The domain here would be all real. There's no, well, the fraction does not have x in the bottom, so that's not going to cause us an issue. No square root, no log. So your domain is going to be all real, except for you plugged in f. So whatever was a restriction with f, we have to carry it on here. It was 1/5. So my domain, x cannot be 1/5. So in interval notation, if I do a number line, negative infinity, infinity, 1/5, I will be removing that point, so my interval will be from negative infinity to the left side of 1/5, union the right side of 1/5 to infinity. Okay, so that will be my domain. So we got all the pieces now. We can plug it in. So this function was 1 minus 5x over 6. And then domain of f of g, that was the first one we did. So that's the negative infinity to 0, 0 to 5, and 5 to infinity. Negative infinity to 0, 0 to 5, and 5 to infinity. So b, and then domain of g of f was negative infinity to 1/5 and 1/5 to infinity. Now there's more choices, but B looks like what we need.